everyone. This movie will be about how to make very nice point cloud in the forest very quick and in the single step. So this is the expected result. This is our trajectory, the black line. So let's use our software, LiDAR odometry step 1, but we change parameters by unclicking this simple GUI, and let's focus on certain parameters. So first of all, we decrease number of iterations to 20, then we increase sliding window to 200 meters, and then we turn off robust and accurate LiDAR odometry. We load data. Give me a second. Okay, so we are loading data and waiting for indexing. Okay, data is indexed. So let's start calculations. And what you can see here, it is very nice, very fast. It requires around 60-70 milliseconds for one iteration. So all data is, let's say, saved in temporary data are saved in preview mode, so you can easily observe what is going on. Okay, so we have a rapidly growing data set. It is very quick. So let's observe that our forest is growing very quick. Very quick. We have already 600 from 4000. So we can observe more and more. It's almost 25% of the survey. Okay. So let's check if everything is okay. It's very okay. It's very okay. Let's continue. We have already 25% of the scope. Let's talk a little about parameters. So I will open program again. So basically speaking, for most of the scenarios, I propose a fully automated way to process LiDAR odometry. But if you would like to play around with parameters, there are plenty of opportunities. For example, the first parameter, threshold of number of poses. So this parameter makes local, let's say, optimization step that every time 20 poses are optimized. So it is like a elastic trajectory that all poses that comes from IMU filter are optimized to obtain nice map, nice point cloud. Another parameter is filter threshold XY inner, and I wrote here that all points inside LiDAR XY cycle radius will be removed. So all points in the 30 centimeters from the LiDAR will be removed. So if you increase this one, you can remove, for example, some objects that they are very close to the LiDAR. Let's find a way again. Oh, we are in the half of the calculation, so let's talk about other parameters quick. So another parameter is the threshold outer. So all points above this threshold, this radius, will be removed. So our LIVOX 360 and MID360 has 70 meters range. So all the points that are far from this distance, they are removed. And if you would like to save during the save, you can also remove data from this radius. So all data that they are affected, for example, by the person who is holding the mandeye, will be removed from this using this parameter. Okay, these are most important parameters for now. So let's check what we have in our preview. This is our preview. Let's check what we have. We have very nice, promising result. Obviously speaking, if you would like to increase accuracy and precision, I advise you to increase number of iterations that you can find it exactly here. This is the number of iterations, so you can just increase it or decrease it. And once you have more iterations, you have more calculations, it means that you need more time to process data set. In our particular experiment, we are using 20 iterations. It means that we have to spend 70 or 100 up to 100 milliseconds for optimization of the 20 nodes. So these 20 nodes here. So once you have, let's say, 20 iterations of 20 nodes, it takes 70 or 80 milliseconds. We are approaching end of calculations. Let's check again how it performs. I am using a preview to justify if I terminate calculations and launch with different parameters. But here I can see that everything looks very, very promising, even we are using not large number of iterations. I am very, very optimistic to continue these calculations. So let's take a look. We have almost 4,000 nodes. It's very quick. It's much faster than the survey. So we are calculating already 7 minutes, and we are almost done. Okay, so we are in the end. So we have 300 meters length of the trajectory, and our trajectory looks like this. Give me a second. Where is our trajectory? I lost again the trajectory. Anyway, we save the data with this is not this program. This is load data. Sorry, it is not this program. This is this one. So this is not this one. This is this one. Oh yeah, I found it. So this is our trajectory. I'm so sorry because I launched many programs and I was so confused. So we back exactly in the same place as we start our calculations. So what we can do now, we can save results. So the results are saving. By saving results, we create a session in such a location that can be used for further processing. So maybe we will skip discussing this type of data. Let's focus on saving points into a single last file, that it is important in this very quick experiment. So we just save it here. All LiDAR odometry runs, and let's play with this in Cloud Compare. So we are saving all point clouds in single LAS. So you can see very easy way, very fast way for obtaining point cloud from Survey in fully automatic way. So what we have our OLAS here, and let's put Cloud Compare here. Let's load it. We have 65 million of points. Let's wait a little once it is loaded. I think we can close our program, so yeah. It's almost done, it is 90%. Oh, and this is our result. So let's change some colors from GPS time to intensity, and let's use high contrast. Let's make some intersection to have very nice subset of data. Let's make very nice subset of data. Okay. Maybe like this. Okay, once we have a subset of data, you can see there are some noisy data around if we put larger. Okay. So to remove such noise, just use saw filter and try to put the standard deviation of 3 centimeters that you can find easily in documentation on the LIVOX. So after that you have very promising result for further calculations. If you take another, let's say, intersection. Oh, sorry, not this one. Oh, I click something that I don't understand. Oh, again. I was trying to make an intersection. Okay, give me a second. Yes. So we have another intersection. Let's make a top view, and we can make further calculations. Okay, so that's all for now. Thank you very much for watching this video. I hope you enjoy about how to make a very quick survey and very quick calculations in fully automatic way. Thank you very much again.